Hello and welcome to Tribe Topper. In this video session, you are going to learn about electromagnetic waves. So what are electromagnetic waves? As the name suggests, these waves consist of waves. So EM waves, we give them a short name as EM wave for electromagnetic waves. These are the waves that are produced actually due to the interaction between an electric field and a magnetic field. So when you have an oscillating electric field, as you can see here along the y-axis, right? So this is an oscillating electric field along the y-axis, and we have an oscillating magnetic field along the x-axis or z-axis. We call this as x, y, and z. So this is along the z-axis. Then these two fields oscillating in the perpendicular directions to each other, due to their interaction, a wave is produced known as EM wave or electromagnetic wave, and that goes out as the EM wave perpendicular to both electric and magnetic fields. So the EM wave produced is perpendicular. The EM wave is perpendicular to both electric field as well as magnetic field in which they are oscillating. So as you can see that electric field is oscillating along the y-axis and the magnetic field is oscillating along the z-axis, then the electromagnetic wave is produced along the x-axis. And then we have a term relevant to this called electromagnetic spectrum. So basically the electromagnetic waves that we get due to this electromagnetic field interaction, they are of different frequencies and wavelengths. So when we arrange them in an order, you can arrange them either in an increasing order of frequency or an increasing order of wavelength. Whatever order you want to arrange it, that arrangement is called the electromagnetic spectrum. So the definition for EM spectrum is just this, that the arrangement of EM waves in the increasing order of frequency or increasing order of wavelength is called electromagnetic spectrum. So EM waves, now here this particular image I have given is for the EM waves arranged in the decreasing order of wavelength and hence increasing order of frequency. As you all know that lambda, wavelength, and frequency, they are inversely related, because if the length of the wave is more, the frequency is less, because frequency is this, how many waves are completed in 1 second. If this length is more, then obviously the number of waves in a second is less. So this particular arrangement I've made is in the increasing order of frequency, so naturally the wavelength will decrease. So we would say the smallest frequency is for radio waves. So sometimes in the exam they ask you to write them in the increasing order. You have to learn this order, right? So radio waves, the lowest frequency, then you write like this, microwaves, then you write infrared rays, so infrared, then visible, then we have ultraviolet, UV you can write, then X-rays, and the highest frequency and the most energetic are gamma rays. If you have to write them in the increasing order of wavelength, in case in the exam the question is about increasing order of wavelength, just reverse this order. Then you will write, start from here, gamma rays, this will be the least wavelength, and radio waves will be the maximum wavelength. So here I'm writing, so radio waves, they have the least frequency and longest wavelength, and gamma rays have highest frequency and shortest wavelength. So this is how we arrange the entire electromagnetic spectrum in the increasing or decreasing order of wavelength and frequency. You have to answer according to the question. And something important about EM waves, that though almost most of the properties for all EM waves, they are different, but they do have something in common as well. That is that they all move at the speed of light in a vacuum, which is exactly 3 into 10 to the power of 8 meters per second. So irrespective of the type, their frequency and wavelength, all EM waves move at the speed of light, which is 3 times 10 to the power 8 meters per second. And another common point between all EM waves but except gamma rays, that all electromagnetic waves other than gamma rays, they are actually produced when electrons, they undergo energy changes, right? When the electrons keep on jumping from the one level to the other level, and based on the kind of photons, these electromagnetic waves are produced. So they might differ, the mechanisms might differ, but they are produced generally as the electrons undergo any energy changes. But gamma rays, they are a bit different in the source, because they are emitted by a nucleus, when you might have heard of the radioactive decay. So actually by the means of the decay or annihilation events, the gamma rays are produced. And one more very important thing about EM waves, whatever kind of questions that are asked, are also based on the uses. So you must know a couple of uses for each one of these. Like, let's start first of all from the radio waves. So they are used in your radio and television. All this radio, television, etc., they use the radio waves. Then we have the microwaves. Don't consider don't consider that microwaves are used just in the microwaves, like for cooking food. That is one use, but even your satellite communication, that is also based on microwaves. Then we have infrared rays. Most probably all of you know the electrical heaters, cooking food, infrared cameras. These are a lot of things which use infrared rays. Then we have visible light. Of course, we use visible light to see the stuff, and all the fiber optics communication that is happening in today's world, that is possible through visible light. Ultraviolet light, they are used in energy efficient lamps, and they actually cause sun tanning. Not a use, but they are responsible for the sun tanning. And X-rays, they are used in medical imaging and treatments. We know X-rays, we do have to check the bone fractures and everything, that uses X-rays. And last one, gamma rays. They are also used in medical imaging and treatments, and also they are used for sterilizing purpose. So these are a few of the uses for electromagnetic waves. So that's all in this video session. In the next video lesson, you are going to learn about wave fronts and rays. Thank you for watching.